Today we're going to be looking at a concept called electrochemistry, and we're going to return to this concept of the pitcher and the catcher. So these guys are all labeled for you. Remember, the pitcher is going to be throwing the ball, and the ball is going to be going through the air. The catcher is then going to catch the ball. So this is one event. However, we can separate this event into two things that are happening. The two things that are happening are the ball's being thrown and the ball's being received. So there's actually two things or two reactions that are taking place. In the process, the electron is being thrown or the ball is being thrown. So this again is a redox reaction where we have a reduction reaction, we have an oxidation reaction. It's one event that's taking place simultaneously, but there are two things that are happening. And again, in the process, we're throwing this electron. So we're going to be looking at electrochemistry today, and we're looking at the definition of electrochemistry. And then we're going to review the lab, and then this is going to be a preface to going into the next section, which is going to be taking a look at what's called a voltaic cell. And we'll get to that in the next section. So this is the definition. Electrochemistry. Electrochemistry, the definition is actually in the word electrochemistry. This is when you use chemicals to create electricity. You use chemicals to create electricity. This is what we did in the voltage lab. What we had is we had a small plate of zinc. And the zinc was sitting inside of a solution of zinc sulfate. On the other side of the paper strip, we had a copper plate. And the copper was sitting inside the copper sulfate. So if you take again the zinc and place it directly in contact with the copper sulfate, as we did in the previous lecture, what's going to happen is you'll have the direct transfer of electrons from the zinc to the copper sulfate. The zinc will then dissolve, and the ball, or the electrons, these will be then transferred to the copper, and the copper is dissolved, and it's going to make that into solid copper. So let's take a look and see what we can do here. We're going to try to separate that by putting the voltage meter in between those two, and we can still transfer those electrons. And so if you remember, we took a voltmeter. Let's draw the voltmeter right about here. I'm going to just put a big V for volt, and the electrons were able to transfer through the electrodes of the voltmeter, and out came two electrons, and then those electrons went into the copper. Now we needed to complete this circuit, which is what's called a bridge, and we're going to see that there's a video that I want you to watch, and it's going to be called a salt bridge. So let's take a look at the two reactions that are taking place. Again, we have a reduction reaction, we have an oxidation reaction. Okay, again, we've got our pitcher, we've got our catcher. So over here, again, we're having our oxidation reaction. Over here is the reduction reaction. And it's the reduction reaction because remember, it's receiving the electrons. It's getting the negatives. If it's getting the negatives, it's becoming reduced. So these two reactions are going to be taking the zinc, and the zinc is in its neutral state, so we're going to put a charge of a 0. And what happens is it is going to dissolve. And as it dissolves, it becomes an ion, much like taking salt, sodium chloride, and putting it into water. It's going to dissolve. It becomes a sodium ion and a chloride ion. So the zinc is going to dissolve, and it's going to produce the two electrons. These are the two electrons that go through the voltmeter and end up getting transferred to the copper over here. So on the other side, those electrons are being taken, and this copper sulfate is not solid copper sulfate, this is dissolved. And so it's going to be in its ionic state. So we can probably say this is going to be the aqueous, so it's dissolved. We can also say this is aqueous as well. And the copper has a charge of 2+. So it's going to receive those 2 electrons over here, and the 2 negatives with the 2+ are going to cancel each other out. And it's going to lead us to copper with a charge of 0. So what we have is we have this 2 electrons that are leaving, flowing through the voltmeter, coming in. And so I'm going to just draw a curved arrow over here. These are the same 2 electrons. The 2 electrons that come out are the 2 electrons that are coming in. And what we have is we have this movement of electrons. We have this flow of electrons. And as the electrons flow, this is what electricity is. Electricity almost has the word electron in it. So electricity is the flow of electrons. What's flowing through the lights right now, through the wires and everything, are actually electrons. It's the movement of these electrons that are being pushed along that help to generate electricity, to make a fan move, to make a stove heated, to make your iPad work or your phone or any electrical device. It's all dealing with electrons. That's what electrochemistry is.